So this is about how electricity is transmitted from a power station to your home. So let's see what happens. It's generated in a power station, let's say, at quite a high voltage. Now we need to increase the voltage up to a very high voltage, which is along those transmission lines which you see, those electricity pylons. So we need to increase the voltage, increase that alternating current. So what do? We use a step-up transformer, and the step-up transformer, that increases the voltage to a very, very high voltage. Now, electricity then travels along those transmission lines at very high voltage, and when it kind of gets towards the other end, we then use another device called a step-down transformer to decrease that voltage back down to a level which we can use in our houses, about 230 volts AC. So the question is, why do we increase the voltage to such a high voltage along the transmission lines? And the idea is this: if we do it at a very high voltage, we can do it at a very low current. And a low current means the wires won't get so hot, so they won't lose so much heat, and less energy will be wasted. So that's why we transmit electricity at high voltages. So, how does a transformer work? Well, let's remember, transformers, they can change the size of an alternating voltage, and they can either step it up, i.e. increase the voltage, or they can step it down, i.e. decrease the voltage. In front of you, you can see that there are two coils of wire wrapped around a sort of iron core, and we have a primary coil, that's sort of the current going in, and then we have the secondary coil, that's the current going out. If we've got more coils on the primary than we do on the secondary, that's a step-down transformer. But if we've got more coils on the secondary than we do on the primary coil, then that makes it a step-up transformer. If you're doing the higher paper, you need to be able to use the equation which connects the voltage on the primary, the voltage on the secondary, the number of turns on the primary, and the number of turns on the secondary. The easiest way to write this is Vp times Ns equals Vs times Np. And what they'll do in a question is they'll tell you three of them, and they'll ask you to calculate the fourth. Here are two examples. There are 50 turns on the primary and 5 turns on the secondary. The voltage on the primary is 230. We need to work out the voltage on the secondary. So we can plug all those numbers into the equation, and we find out that 230 times 5 equals Vs times 50. We flip it around, and we find that 50 times Vs equals 1150, and then we divide that number by 50 to find out that Vs equals 23. There's another question here which you can also go through as well, though I'm not going to go and do that now.